So in this next video, let's start with quantum mechanics. Wave-particle duality. Matter and light exhibit both particle and wave characteristics. De Broglie's hypothesis, lambda is equal to h by p. For example, electron diffraction demonstrates wave nature of particles. Schrödinger equation is the fundamental equation describing quantum systems. It is impossible to simultaneously measure position and momentum with respect to with absolute precision. Quantum cryptography is basically security based on measurement uncertainty. Quantum cryptography is security based on quantum measurement uncertainty. Quantum cryptography is basically security based on measurement uncertainty. Scanning tunneling microscope (STMs). Particles can penetrate potential barriers higher than their kinetic energy. Quantum tunneling. Quantum tunneling is कि particles can penetrate potential barriers for higher than their kinetic energy. Quantum tunneling. Quantum harmonic oscillator describes vibrations in systems like molecules, lattice vibrations, etc. Superposition is a system exists in multiple states simultaneously until measures. A system exists in multiple states simultaneously until measured. Entanglement is correlation between quantum states of particles even at large distances. Correlation between quantum states of particles even at large distances is entanglement. Spin is an integral intrinsic angular momentum uh, plus minus h cross by 2 for electrons. Pauli exclusion principle. No two fermions can occupy the same quantum state. No two fermions can occupy the same quantum state. Bose-Einstein statistics. Bosons, for example, photons, Fermi-Dirac fermions. Quantum measurement collapses a wave function into one eigenstate of the observable. Quantum measurement collapses a wave function into one eigenstate of the observable. क्वांटम मेजर अगर किसी का क्वांटम मेजरमेंट करते हैं तो वेव फंक्शन को एक आइगन स्टेट में कोलैप्स कर देता है. Atomic and molecular physics. Atoms consist of nucleus and electrons orbiting in discrete energy levels. Atoms consist of nucleus and electrons orbiting in discrete energy levels. Spectral lines arise from electronic transitions between these levels. Fine structure of spectra, splitting of spectral lines due to relativistic corrections and spin-orbit coupling. For example, atomic clocks में use होता है. Zeeman effect, splitting of spectral lines in magnetic field, and Stark effect is splitting of spectral lines in an electric field. Lasers कैसे काम करते हैं? Spontaneous emission, stimulated emission and absorption. Transition probabilities and selection rules. Rotational spectroscopy and vibrational spectroscopy. फिर Raman spectroscopy is basically inelastic scattering of photons shift in wavelength. Inelastic scattering of photons shift in wavelength. Inelastic scattering of photons shift in wavelength. Infrared spectroscopy, absorption of infrared light due to vibrational transitions. Absorption of infrared light due to vibrational transitions. NMR, resonance absorption by nucleus fins in a magnetic field. MRI scanners. Resonance absorption by nucleus fins in a magnetic field. MRI scanners. ASR is resonance absorption by unpaired electrons to study free radicals. NMR is resonance absorption by nucleus spins in a magnetic field, or ASR is resonance absorption by unpaired electrons to study the free radicals. Frank Condon principle is transitions between electronic states are most likely when nuclei remains stationary. Stimulated emission of radiation produces coherent light, laser or microwaves maser. Nuclear and particle physics. Alpha decay is emission of helium decay. Beta decay is conversion of a neutron to a proton with emission of electrons or positrons. Gamma decay is emission of photons from excited nuclear states. Liquid drop model explains binding energy and nuclear stability, semi-empirical mass formula, and shell model nuclear energy levels based on quantum shells magic numbers. Nuclear energy levels are based on quantum shells magic numbers. Nuclear reactions, transformation of nuclei during collisions or energy absorption. Nuclear reactions are basically transformation of nuclei during collisions or energy absorption. Binding energy is the energy required to disassemble a nucleus into its components. Energy required to disassemble a nucleus into its components. Neutrino physics, study of neutron interactions with matter. Thermal neutrons, slow neutrons used in thermal reactors. Neutron scattering, probing material structures. Forces mediated by bosons, photons, gamma, electromagnetic force, WZ bosons, weak force, gluons, strong force, gravitons, gravity. Standard model is a structural theoretical framework describing elementary particles and forces except gravity. Particles, fermions, quarks, and leptons, and bosons, force carriers. High energy physics is in high energy physics we accelerate particles to high energies to probe subatomic structures. For example, cyclotron, synchrotron, and linear accelerators. Higgs mechanism explains the mass generation for particle via interaction with the Higgs field. Neutrinos are nearly massless particles interacting weakly with matter. Neutrinos are nearly massless particles interacting weakly with matter. Dark matter is non-luminous matter inferred from gravitational effects, and dark energy causes accelerated expansion of the universe. Dark energy causes accelerated expansion of the universe. Dark matter is non-luminous matter inferred from gravitational effects. Neutrinos are nearly massless particles interacting weakly with matter. Electron, muon, and tau neutrinos, oscillation phenomena, change in neutrino type during travel. Cosmic rays, high energy particles originating from space. Primary cosmic space, proton alpha particles, and secondary cosmic rays produced in atmospheric collisions. Next is solid state physics. Solids have a periodic arrangement of atoms or ions forming crystal lattices, simple cubic, body-centered cubic, and FCC-HCP. Band theory of solids, formation of energy bands due to overlap of atomic orbitals. Conductors, overlapping valence and conduction bands. Overlapping valence and conduction bands. Intrinsic semiconductors, pure materials like silicon and germanium. Extrinsic semiconductors doped with impurities to enhance conductivity, जैसे N-type, P-type. Superconductivity is zero electrical resistance and expulsion of magnetic field. Meissner effect below a critical temperature. Zero electrical resistance and expulsion of magnetic field below a critical temperature. Zero electrical resistance and expulsion of magnetic field. BCS theory, Cooper pair formation due to electron-phonon interactions. Cooper pair formation due to electron-phonon interactions. MRI machines and maglev trains. Phonons, quanta of lattice vibrations in a solid, acoustic and optical phonons. Diamagnetism, weak repulsion to magnetic fields. Paramagnetism, alignment of magnetic moments with the field. Ferromagnetism is a strong permanent magnetization. Dielectrics are insulating materials that polarize in the presence of an electric field. Dielectrics are insulating materials that polarize in the presence of an electric field. Specific heat, specific heat explained by classical Dulong-Petit and quantum models, Debye and Einstein models. Quantum confinement is a behavior of electrons in materials where dimensions are reduced to the nanoscale. Hall effect is generation of voltage perpendicular to the current flow in a conductor under a magnetic field. Generation of voltage perpendicular to the current flow in a conductor under a magnetic field. Ferroelectricity materials exhibit spontaneous electric polarization reversible by an electric field. Piezoelectricity electric charge generation under mechanical stress. Piezoelectricity is electric charge generation under mechanical stress. Nanomaterials enhanced properties due to high surface area to volume ratio. Last is electronics. So diodes allow current to flow in one direction. PN junction, Zener diodes, LEDs, transistors, semiconductor devices used for amplification and switching, BJT and FET. BJT is current control device with three regions and FET is voltage current control device जैसे जंक्शन जिसमें जंक्शन FET and MOSFET होता है. Thyristors and triacs are used for controlling large currents, particularly in power applications. Amplifiers are devices that increase the amplitude of signals. Operational amplifiers are used widely for amplification, filtering, and signal processing. Gain is output to input signal, ratio of output to input. Feedback is negative feedback stabilizes the gain, while positive feedback causes the instability or oscillation. There are three types of ICs: monolithic ICs, digital ICs, analog ICs. Monolithic single chip, digital ICs में logic gates यूज होते हैं और analog ICs में op amps यूज होते हैं. Rectifiers convert AC to DC, half wave, full wave. Voltage regulators, they maintain a constant output voltage despite input variations. Switching regulators, more efficient than linear regulators, buck boost, etc. Or inverters convert DC to AC. Sensors are devices that detect physical quantities, temperature, pressure, light, and convert them into electrical signals. Thermistors, strain gauges, pressure, photodiodes, light, etc. Accelerometers motion measure करते हैं. Modulation is the process of varying a carrier wave to encode information, AM, FM, PM, and demodulation is the extracting the original signal from a modulated carrier. VLSI is integration of thousands of millions of transistors into a single chip. Moore's law is the observation that number of transistors on a chip doubles approximately every 2 years. So this was it. Thank you for watching. See you in the next one.